Biography of Christiaan Huygens, scientist and discoverer of Titan satellite. Profile and biography of Christiaan Huygens. He is known as a scientist and inventor. He is known to be very skilled in the fields of mathematics, physics, and astronomy. One of Christiaan Huygens' works was the explanation of waves, which became known as the Huygens principle in physics. In the field of astronomy, Huygens is known to have discovered the satellite Titan on the planet Saturn, which is known to be the second largest satellite in the solar system. His contribution of thought and discoveries in the field of astronomy made him one of the best scientists in the world. Biography of Christiaan Huygens. Christiaan Huygens was born on April 14, 1629 in Hague, Netherlands, to a prominent family. His father, Constantin Huygens, was a physics graduate and diplomat. He hoped that his son would become a great scientist, so he asked Merson and Rene Descartes, two famous scientists at that time, to give courses to the young Huygens. Huygens then studied geometry, mechanics, and the ability to play musical instruments at home until he was 16 years old. His teacher, who was very influential, was Descartes, who managed to stimulate his interest in mathematics. Christiaan Huygens studied law and mathematics at Leiden University between 1645 and 1647. Van Schooten taught him mathematics. Then, from 1647 to 1649, Huygens studied law and mathematics. Luckily, he studied mathematics with John Pell, then correspond with Marcin, in 1649. Huygens went to Denmark as a diplomat and hoped to continue to Stockholm to meet Descartes. Unfortunately, the weather didn't cooperate. Huygens' scientific work was first published in 1651, namely Cyclometria, which discussed circles. Then, in 1654, he produced De Circuli Magnitudi and Inventa, which discussed various scientific issues. Discoverer of Titan satellite. He also took an interest in making lenses and telescopes. In 1654, he discovered a new method of making lenses. A year later, from his artificial lens, he succeeded in observing and finding Titan satellite on Saturn. The lens he developed was later used to observe planets, satellites, and the Orion Nebula. That same year he went to Paris and met Boléau, who advised him to study probability with Blaise Pascal and Fermat. When he returned to the Netherlands, Huygens produced his work on probability calculus, namely D ratiocines and Ludois Nex. He discovered Saturn's rings. However, this is different from the theory about Saturn's rings previously proposed by Roberval, Boléau, and Galileo, who several years earlier considered Saturn's rings to be part of Saturn. In 1659, Huygens published his work Systema Saturnium, which described the stages and phase changes of Saturn's rings. The observations of another scientist, namely Fabry, in 1665, apparently confirmed Huygens' theory. In 1656, he patented his invention of the pendulum watch, which was able to increase the accuracy of time measurement. He expressed the theory of pendulum motion in Horologium Oscillatorium Siv de Motu Pendulorum, 1673. He also discovered the law of centrifugal force from uniform circular motion. In 1661, Huygens went to London to find out more about the Royal Society, which met at Gresham College. He paid great attention to the British scientists. Furthermore, Huygens then continued to make contact after that. He showed his telescope, and British scientists used it. The King and Queen of England used the telescope to observe the Moon and Saturn, inventing the pendulum clock. While in London, Huygens saw Boyle's invention of the vacuum pump, and he used it. In 1663, Huygens became a member of the prestigious scientific institution Royal Society. Huygens patented his pendulum watch design that same year. Huygens' experiments on the collision of elastic bodies showed the error of Descartes' law. Collisions. This theme was raised at a meeting of the Royal Society in 1668. The Royal Society asked a question about collisions, and Huygens answered it by experimenting with the momentum of two objects before the collision being the same as their momentum after the collision. The answer was later called the law of conservation of momentum. Circular motion was the theme of Huygens' research at that time. But he also thought about Descartes' theory of gravity, which was based on rotating matter, which he called vortices. There is something wrong with Descartes' theory. In 1669, Huygens visited the Academy to discuss this issue. After that, Roberval and Mariotte corrected Descartes' views. As a result of frequent back and forth between France and the Netherlands, Huygens fell ill in 1670 before leaving Paris, France. Huygens promised not to publish his research on mechanics before sending it to the Royal Society. In 1671, Huygens returned to Paris. However, in 1672, King Louis XIV invaded the Netherlands. Huygens saw his position as difficult, and it was very important for him to be in Paris. French scientists strongly supported his research. In 1672, Huygens met Leibniz in Paris. After that, Leibniz regularly visited the academy. Leibniz was indebted to Huygens because he studied mathematics with Huygens. In the same year, Huygens learned about the working principles of Newton's telescope and light. He tried to criticize Newton's theory of light, especially regarding color, wave theory of light. Huygens supported the view that light is emitted by the action of waves in a medium, and not by particles emanating from a source of illumination. With this model, he was able to explain what reflection, refraction, and even the complex phenomenon of double refraction were observed in some crystals. He then published his findings in Treatise on Light. Huygens' views contrasted with those of Isaac Newton, who generally propagated the view that light was a stream of particles. In 1675, Christiaan Huygens patented the pocket watch he invented. He also invented many other devices, including 31 notes for octave keyboard instruments returned to the Netherlands. Huygens moved back to The Hague in 1681 after suffering from a serious illness. He attempted to return to France in 1685, but the revocation of the Edict of Nantes hindered his progress. This was because he was a Protestant Christian, which at that time was banned in France. In 1684, Huygens published the Astroscopia Compendiaria, which presented his new airborne tubeless telescope with a focal length of 123 feet. Huygens' treatise on light was finally printed in 1690. Huygens speculated in detail about life on other planets in his book entitled Cosmotheros, next entitled The Celestial Worlds Discovered, or Conjectures Concerning the Inhabitants, Plants, and Productions of the Worlds and the Planets. In his book, he imagines a universe full of life. Much of it closely resembles life on 17th century Earth. After publishing many works and making important discoveries, Christiaan Huygens, who was known at that time as the most influential scientist, died on July 8, 1695 in The Hague, Netherlands.